So keeping that in mind, let's take a look at a few of these. So you notice how, so this is 30 degrees, right, and the side opposite the 30 degrees is 5. So that's going to be our y in terms of our reference sheet. And this you'll always have. So if this is 5, then the side opposite the 60 degrees is 5 square root 3. And my hypotenuse is double the 5, so that's going to be 10. Okay. If you look at number 6 here, the side opposite the 30 degrees is the 8 square root 3. Okay, so that means this is my y value. So the side opposite my 30 degrees, this is going to be 8. And my hypotenuse is double that, so this is going to be 16. Number 2, very similar. If this is 2, this is 2 square root 3, and the hypotenuse would be 4. Okay, now, we take a look at number 3. Okay, in this case we're given the hypotenuse. So the side opposite the 30 degrees is half that, so that's 7/2, or 3.5. But you're not gonna see it as a decimal, you'll see it as a fraction, so leave it as 7/2. And then this side opposite the 60 degrees would be 7/2 times the square root of 3. Here, this is the side opposite the 60 degrees. This is the 30 degree side. And of course, this is the hypotenuse, so this is represented by 2y. This is y, square root 3. So my side opposite the 30 degrees is going to be half of 8, which is 4. And this side here is going to be 4 square root 3. Okay, keep in mind, be careful, you have to pay attention to the orientation of the triangle. Okay, so like here, this is opposite the 60 degrees. So that means this value here that's in front of the square root 3, that's the value of the side opposite the 30 degrees. So this is going to be 3. And then my hypotenuse would be double that. So that's going to be 6. Now, I want to give you, oh, here's a good one. Okay. So here, very similar to the situation we had with the 45, 45, 90 triangle. Okay. So here, that 3 square root 3, that's opposite the 30 degree angle. So based on our reference, that is y, okay? And this side over here opposite the 60 degree is y square root 3. Okay, so to get this side here, which is represented by n, I need to do 3 square root 3 times the square root of 3. Okay, do not fall into the trap of assuming that 3 square root 3 is actually the side opposite of the 60 degrees, because it's not. So here, when I multiply this out, I'm going to get 3 square root 9. And the square root of 9 is 3, so my answer is actually 9. So this side length is actually 9. And then my hypotenuse, remember, is double my y. So when I multiply 2 times 3 square root 3, what I get is 6 square root 3. Okay, you can only multiply whole numbers by whole numbers and square roots by square roots. Okay. So that's an example of that. The rules still apply here, okay? If this is a side opposite, this is the value opposite the 30 degrees, then we have to multiply that whole value times the square root of 3 to get that the length of that side opposite the 60 degrees. Okay. I wanted to show you one other example to show you how, so sometimes you'll also see like this. Now this is opposite of what the reference sheet tells you, okay? The reference sheet is drawn like this. Okay. Notice how in this example, my blue example, I have 60 degrees in this corner, okay? So again, you have to pay attention to the angles, okay? So this 4 is actually the side opposite the 60 degrees, which is y square root 3. Okay, so to find out what the value of the side length opposite to 30 degrees is, I have to divide both sides by the square root of 3. Now, very much like the 45, 45, 90 triangles, I cannot leave the square root in the denominator. So I rationalize the denominator by multiplying by the square root of 3 over the square root of 3. That does two things. One, it gets rid of the square root in the denominator because square root 3 times square root 3 is square root 9, which equals the whole number 3. That's for starters. Second is I'm not changing the value because anything divided by itself is 1. So I'm just changing the format, but not the value. That's why we're allowed to get away with this. So, and then 4 times the square root of 3 is just 4 square root 3. Okay, and so this, that value here, that's my y value, and the value of the side opposite the 30-degree angle. Now to double this for the hypotenuse, all we have to do is multiply this 4 square root 3 over 3 times 2. And when we do that, we just multiply fractions, multiply straight across. Okay, now 4 times 2 is 8, and we can't do anything with the square root of 3. So that would be the value of my hypotenuse. Okay, so the good news is you'll always be given this shortcut reference, very much like the other special right triangles, but you gotta pay attention to where the angles are located, just like my blue triangle here, and don't automatically assume that the position of the number in the triangle is actually what is given, because remember, everything revolves around this angle opposite, or I should say, everything revolves around the length of this side opposite the 30 degrees. And in my blue triangle, I didn't have that. So just keep that in mind. The other type of special right triangle that we have is a 30, 60, 90 triangle. And that is created from an equilateral triangle. Okay, now an equilateral triangle, all three sides are congruent. It also means that all three angles are congruent. Okay. But if we divide this equilateral triangle in half, okay, with a perpendicular bisector, we get two smaller triangles, each with a 30 and a 90 degree triangle. Okay, and typically what we get is we typically look at it like this. And that is how it's referenced on your MCAS reference sheet. Okay, so with the perpendicular bisector, it cuts this base in half. Okay, so that means this is half of the other leg. So I take the one side of the leg that's congruent and I cut it in half. So we can look at it as if this side opposite the 30 degrees is half of the hypotenuse, because this is my right triangle, or we can look at it as this side length is double whatever that is, and that's supposed to be a y, by the way. It's half of whatever the other side of the equilateral triangle, or in this case, what creates our hypotenuse with that right angle. And how your MCAS reference sheet has it is that this is the 30 degrees, this is the 60 degrees. Okay. Okay, so that's where, so we know by dividing this side length in half that was originally the same length as this, we know that that side opposite the right angle, or acting as our hypotenuse, is double this side length that we cut in half. So then that just leaves to determine what is the length of this other side. Well, if we, I'll just mark this B for now. If I give this a value, I'll give this a value of 3. That would mean this hypotenuse is double, so that is 6. So let's plug that into Pythagoras' theorem and see what we get. So we have 3 squared plus my other leg squared, which I'm solving for, and the hypotenuse squared. So this is 9 plus b squared equals 36, because 6 times 6 is 36. Then to solve for b, I have to subtract 9 from both sides. So what I get is b squared is equal to 27. Now, my last step is always to take the square root. And like we did in the 45, 45, 90 triangle, I am going to simplify this into simplest radical form by factoring out as many perfect squares as I can. And 27 can be factored into 9 times 3. And the square root of 9 is 3, leaving me with the square root of 3. So this side opposite the 60 degrees is going to be whatever the length of y is times the square root of 3. So it doesn't have anything to do with the square root 3 will always be there. So just to show you another example, we'll use 5. So if my one side is 5, my one leg is 5, I'm looking for b, that would mean my hypotenuse is 10. So this is 25 plus b squared equals 100. 100. Subtract 25 from both sides. I get b squared equals 75. And so the length of my other missing leg is the square root of 75, which, again, I can factor into 25 times 3. And the square root of 25 is 5, square root 3. So the pattern that we have found is that a 30, 60, 90 triangle always, this side length here across from the 30 degrees, the hypotenuse will always be double that length, and the remaining leg across from the 60-degree angle will be the length of y times the square root of 3.